Forward to number 3, lesson 3, problem number 1. Noah is running a portion of a marathon at a constant speed of 6 miles per hour. Complete the table to predict how long it would take him to run different distances at that speed and how far he would run in different time intervals. So essentially, we are completing the table. All that extra stuff at the end is just we're finding out how long it would take him to run these different distances. But a really helpful thing here for us would be to know what the constant of proportionality is, so we would know what to multiply the left-hand column by to the right to get these blanks. And we're given it right here, really. Okay, 6 miles per hour. So miles traveled at 6 miles per hour. When an hour has passed, this is a no-brainer. I'm going to go 6 miles. All right, so that is meant to be simple there. All right, that very first one. And that's really the key to unlock everything. Now, some of these can be done mentally. If I can go 6 miles in 1 hour, then in a half of an hour, I should be able to travel half of that distance, which is 3. But now we're getting into some tougher fractional answers down here at the bottom. So what's really helpful to have is a constant number that you can just multiply this by to get over to this side. Like, what could I multiply 1 by to get 6? That's my constant of proportionality. Also, it can be found by taking your y value, one of your y's, and dividing by its corresponding x, which would be 6 divided by 1. Same thing as what I would have done in my head if I just asked myself, what do I multiply the left side by to get the right side? So this is my constant. Once I have this constant number, it can be applied to every situation from left to right. So that will help me with this one, where I have to do 1 1/3, which is equivalent to 1 times 3 plus 1, 4/3, multiplied by 6 over 1, my constant. The 6's, 3 goes into this twice, 3 goes into that once. So this is really the same as 8. So I would expect in 1 1/3 hour to go a little bit more than 6 miles. I would go 8. Now, if I want to go in reverse and I want to come back from where I was, then we need to remember back in our scale drawing lessons that the other direction would be the reciprocal of our scale factor, which here is the proportion. Our constant of proportionality is 6. So to bring us back, we would multiply by a 6th, or 6 reciprocal. So let's do 1 1/2. If we're going to come back from 1 1/2, 1 1/2 is equivalent to 3/2. And let's multiply that by 1/6. That would give us 3 over 2 times 6 is 12, which reduces to common factor of 3 goes into itself once, and 3 goes into that 4 times. So it would take us a quarter of an hour to go 1 1/2 miles. Same thing with 9. 9 over 1. We want to come backwards, so we're multiplying by 1/6. 1 over 6. This is 9/6, which reduces to common factor of 3, goes into it 3 times and twice, 3/2. You might want to write it as 1 1/2 or 3/2. Either ones would be fine there. And then 4 1/2. So we're going to take a 1/6 of that. 4 1/2 is equivalent to 9/2. 4 times 2 is 8 plus 1 is 9. And we multiply that by our reciprocal of our constant, and that's going to give us 9 over 12, which reduces common factor of 3, goes into 9 3 times, and it goes into 12 4. So it would take us 3/4 of an hour to go 4 1/2 miles. We got all this information just from having the constant of 6 miles per hour. Of course, we could transfer all these into minutes. 60 minutes, 30 minutes. 1 1/3 would be an hour and 20 minutes. A quarter of an hour is 15. Hour and a half is 1 minute, or hour and 30 minutes. 3/4 of an hour, you'd have to break it up into 15s. That would be 45 minutes. So you would know how long each of these would take to go those specific distances if Noah continued to run at that pace.